Okay, this is day 2 where we're going to be looking at arithmetic sequences and function rules. I would like you to flip your packet open to page 6. If you don't have a packet, please go ahead and get one at the front. And on page 6, I'd like you to complete the warm-up. So please go ahead and pause at this point. Alright, so when we go to do this warm-up, we are looking at, for the first problem here, the difference between 1 and 4, 4 and 9, 9 and 16 is 3, 5, and 7. You can see the first difference is not constant, so it is not linear. The second difference between 3 and 5 and 5 and 7, the difference is 2. That makes this a quadratic function because the second difference is constant. So what we're going to look to see here is whether, when we plug in our first term, 1 squared equals our first term, which is 1, or is it off by a little bit? In this case, it is 1 squared is equal to 1. 2 squared is equal to 4, which is the second term. 3 squared is equal to 9, which is the third term. 4 squared is equal to 16, which is the fourth term. So n squared is your function rule. So we write it as a of n equals n squared. Yesterday we had a problem where when we plugged in the first term, we were slightly off, like this was equal to 2, this was equal to 5, 10, and 17, because this was really n squared plus 1. We had to add 1 to get that the sequence that we have. So that's our function rule for the first one. Second problem here, we go 8 is the first, 2, 5, 8, and 11. So that's the first 4 terms here. So the difference between each of those is 3. We're adding 3 each time. This makes it a linear function. So when we have a linear function, at this point, this is what we do with this. We look to see, again, we're going to be doing different things with this later after today's lesson. But we're looking to see our slope. Our slope, m, is 3. And our y-intercept, b, is, again, that is what the y value is when x is 0. This is the context you understand right now. So we're going to back this up, because this is the first term. We won the 0th term. So instead of adding 3, we're going to take 2 and subtract 3. And we're going to get negative 1. So it gives us a b of negative 1. So our function rule is a of n equals 3n minus 1. All right. I'd like you to take out your homework from last night, which is page 7. Again, since I wasn't there, I did not upload notes. This is not page 7. I apologize. Your homework was page 5. So let's make sure your answers are correct on here. Again, your assessment for this unit is open notes, so we need to make sure you have the right answer. So the first term is 1. Second term is 7, so you plot 2, 7. Third term is, no, I lied. The first term, I can't see this. The first term was 7, 1, 7. Second term is 11. Third is 15. Fourth is 19, 23, 27, 31. Second problem here, again, they're asking for the next 4 terms and then graph. So this goes negative 10, negative 5, 0. The next 4 terms are 5, 10, 15, 20. So we're plotting, our first term is negative 10, plot that point. Second term is negative 5, etc. So that's what it looks like. Next one here. First term is 101, 202, 303. So it goes to 404, 505, 606, 707. So we plot the first, second, third, fourth, 5, 6, 7th term. And that's what it looks like. Number 4, we are, what are we doing here? We are subtracting 8. Subtracting 8 each time. So it becomes negative 9, negative 17, negative 25, negative 33. So we are applying the first term as 15, the second is 7, the third is negative 1, fourth is negative 9, etc. The next set of problems for homework were whether this converges or diverges. And if it converges, we're going to provide the limit. Now, again, since this is pre-calculus, we're going to just give the limit in kind of like end behavior notation. Next year in Calc with Apps, you'll be dealing with limit notation and throughout your calculus career. But we're going to just start with this today. So our function rule is n squared. So a of n equals n squared. So as we are plugging in n values, this is going to consistently get bigger and bigger and bigger. 100 squared, a million squared, etc. It's just getting larger and larger and larger. It's not approaching a number. I mean, you could say it's approaching infinity, but we don't write it that way. That is the same as diverging. So this is a function that diverges. 1/2, 1/4, 1/16. It's getting smaller and smaller and smaller. the function rule is 1 over 2 to the n. So if we plug in 1 over 2 to 1,000 power, this is a teeny tiny fraction, so it's getting closer and closer to 0. So this converges, and in end behavior notation, as x approaches infinity, f of x approaches 0. So we just look at that right end behavior. This is a linear function. Linear functions diverge. They do not approach an asymptote. If you're not so sure about that, go ahead and ignore my dog. Plug in some numbers here, and you can just see they're just getting 3 times 1 minus 2, 3 times 2 minus 1, 3 times 10 minus 1, 3 times 1,000 minus 1 is getting larger and larger and larger. So it's just diverging, not approaching a single number. Okay, so for this problem here, when we write it in standard form, we end up switching this around. It becomes 3n minus 1 over negative 3n plus 2. This is a rational function. So again, we mentioned yesterday that we're using our rational function rules for horizontal asymptotes. And here notice that this is an n to the first over an n to the first. So when we have the same degree, we steal the leading coefficients, and that becomes our asymptote. So it's y equals 3 over negative 3, which is y equals negative 1. So this is converging and approaching negative 1. So as x approaches infinity, f of x is going to approach negative 1. 2n minus 1 over n plus 1. So notice the degrees again are the same, n to the first over n to the first. So we're going to steal the leading coefficients. So a 2 over a 1. So y equals 2 over 1, or y equals 2, is the horizontal asymptote that this is going to converge to, approach. So this converges. As x approaches infinity, f of x approaches 2. This is 1/2. 0.5 is the same as, stop that dog. 1/2 to the n power. So 1/2 to the first, second, third, 1,000, a million is getting smaller and smaller and smaller and smaller, and it's actually approaching 0. So as x approaches, this is converging. As x approaches infinity, f of x approaches 0. So that's the homework. Today's lesson is identifying the terms of the arithmetic sequence and find its function rule. So we are on page 7. What is an arithmetic sequence? Well, what makes something arithmetic is that we are adding or subtracting a constant value. So we are adding and subtracting a number. Adding or subtracting a number, and that makes it arithmetic. If you are multiplying by a constant, that's called a geometric sequence. So when we add or subtract a constant, it's arithmetic. So this is arithmetic sequences defined. A of n, which is any term. So if we want the 50th term, the 1,000th term, the 4th term, we're going to take a of n minus 1, which is the term before, and then we're going to add this constant difference. So d is called constant or common difference. So when we look at these notes here, we're going from 4 to 7 to 10 to 13. We are going to determine if it's arithmetic. Well, we notice that we are adding the same value each time. So if we're adding the same value each time, then this is going to be an arithmetic sequence because we're adding a constant. Next one here. Show that the following sequence is arithmetic. So we don't have a list of numbers, so we have to make a list of numbers. So we're going to go and find the first term. Normally we write it as a of 1, but since this is defined as s of n, we're going to make this s of 1. So 3 times 1 plus 5 is 8. Second term, 3 times 2 plus 5 is 11. 3 times 3 plus 5 is 14. And then once you are at that point, you can see that between 8, 11, 11, 14, we're adding 3. We're adding a common difference of 3. And our first term, which we normally write as a of 1 for our formula, in this case it's s of 1, is 8. So this is the common difference of 3, and our first term, a of 1, is 8. Second problem down below, show that the sequence is arithmetic. So again, we're plugging in the first, second, and third term here. So first term, 4 minus 1 equals 3, 4 minus 2 equals 2, 4 minus 3 equals 1. We are subtracting 1 in between the 3 and the 2, and the 2 and the 1. You're subtracting a constant that makes it arithmetic. Our first term, a of 1, which in this case is t of 1, is 3, and our common difference is negative 1. So I'm going to give you a minute to copy down anything you haven't copied down yet. Okay, we have, what letter is that? B of n equals 2n minus 5. So here what we're going to look at is the first term. So they're looking for you to write out the first 4 terms and find the common difference. First 4 terms of the common difference. So b of 1 is 2 times 1 minus 5, which is negative 3. 2 times 2 minus 5, which is negative 1. 2 times 3 minus 5, which is 1. 2 times 4 minus 5, which is 3. The common difference is 2. We're adding 2 in between each. So our common difference is 2. And these are the first 4 terms. That's all it asks for on that. Now this, again, you don't have to memorize formulas. Your formative is going to be open note. This is the nth term of an arithmetic sequence formula, where a of n is equal to, yours only says a. It's leaving it more generic. You can go ahead and put a of 1 in for here for now, plus n minus 1 times d. So a of 1 is your first term, d is your common difference, n is the term number we're on. So the 8th term would be an n of 8. So what this is a shortcut, because I can keep extending this pattern if I wanted to find like the 12th term. I could just keep extending this pattern to get the 12th term. But if I asked you for the 112th term, you wouldn't want to keep extending that pattern. You need a formula to do that. So this is the formula that's going to help you find any term of an arithmetic sequence. So we need to find the 13th term of an arithmetic sequence that goes 2, 6, 10, 14, and 18. So since it's the 13th term, n is equal to 13. The first term, a of 1, is equal to 2. And a of 13 is 2 plus n minus 1 times 4. So 2, which is a first term, a of 1, 2, plus 13 minus 1, because it's the 13th one, times 4. So adding 4, adding 4, adding 4 again is your common difference. So we are going to simplify that, and a of 13 is 2 plus 4 times 12. 48 plus 2 is 50. 12th term. So we're trying to find when n is 12. The first term from here is 2. And our common difference between 2 and 4 and 4 and 6 is also a common difference of 2. This is not always the same number. It just worked out that way this time. So a of 1 is 2. First term is 2. Common difference is 2. N is 12. So we go to our formula here, and a of 12 is going to be equal to the first term, 2, plus 12 minus 1, n minus 1 times 2. So 22 plus 2 is going to be 24, which is the 12th term. Okay, go ahead and flip to the next page. On this last page of notes here, this is where it gets a little bit more complicated, and I know you're looking at this and it's already done here. But they're asking for 3 things here. They're not giving you the first term. They're not giving you any way of finding the common difference in an easy way. They're giving you that the 8th term of an arithmetic sequence is 75, and the 20th term is 39. So a of 8 is 75, a of 20 is 39. So between the 8th term and the 20th term, there are 12 common differences. So again, we added our common difference 12 different times. So I'm going to use this information. I know that I started, our 8th term was 75. At 75, I added 12 common differences, because there's 12 between the 8 and the 20, and I ended up with 39. I subtract my 75, I divide by 12, and my common difference is what I solved for, which is negative 3. That's my first step, common difference. Then what they would like is the first term. So I'm going to be using the nth term rule for the next 2 problems here. I know that the 8th term is 75, so that's what I'm going to use here. You can actually do this with like the 20th term is 39, but I just usually use the first bit of information here. So a of 8 is the first term plus, since n is 8 for the 8th term, 8 minus 1, times our common difference, which we solved for, which is negative 3. So we know a of 8 is 75. So 75 equals the first term, which is a of 1, plus 8 minus 1 times negative 3. So this is 75 plus the first term minus 21. So we add our 21, and our first term is 96. Finally, since I have my common difference and I have my first term, they want a function rule, essentially. They want an explicit formula here. So we're going to use the nth term formula again. A of n equals our first term, a of 1, which is 96, plus n minus 1 times our common difference, which is negative 3. We're going to distribute. That actually is not an incorrect answer, but I'm going to simplify it completely. So this is 96 minus 3n, and negative times negative is plus 3. So a of n is equal to negative 3n plus 99. Whoops. Example 8 down below is just another example, so you'll have a couple of these in your notes that you can use when you're going to do homework, or if you are going to take an assessment. This will show, a question like this will show up on it. So find the first term and the common difference and give an explicit formula for this arithmetic sequence before. Below, again, their 8th term here now is 8, and the 20th term is 44. So there are 12 common differences between 8 and 20. 20 minus 8 is 12. We started at 8 and we ended up at 44. So 8 plus 12 common differences, the dog's going wild upstairs, equals 44. Subtract the 8, divide by 12, and our common difference here is 3. Now we want to go ahead and solve for our first term. So we're going to use that common difference and the nth term rule. So second step, we're going to use that the 8th term is 8. You could also use the 20th term as 44, but I just used this one. A of 8, which is 8, is the first term which we're solving for, plus n is 8 because it's the 8th term, minus 1 times 3. If instead you wanted to do 44 equals a of 1 plus 20 minus 1 times 3, you would actually get the same answer. 21 plus a of 1 equals 8. We subtract 21, and the first term is negative 13. So we plug into our nth term formula here. A of n equals the first term, a of 1, which is negative 13, plus n minus 1 times 3. Distribute, distribute, combine like terms, and this is the explicit rule for the arithmetic sequence. So what you're going to complete right now for the rest of class period and for homework is page 9 in your packet. So page 9 in your packet, just go ahead and look at the directions of what they want you to do for each one. And then there's some word problems. And again, please try all these problems, do the best you can on them. We'll go through any questions you have when I see you again. So again, page 9 is your assignment, and you're going to work on this for the remainder of this period. You should still have another maybe 30 minutes left at least. All right, thank you.